Hello, this chapter is going to focus on solving systems of linear equations. And so first of all, let's talk about what a system of linear equations looks like. I've got a bit of a cold, so I apologize for any coughing or hacking that goes on here. Alright, so these equations here, these two equations are linear because the variables are first degree variables. This is x to the first, y to the first. So this is said to be a system of linear equations where you have two equations and two unknowns. This is a system of linear equations where you have two equations and three unknowns, and shows you can use subscripted variables instead of the standard x, y, and z. So I used x1, x2, and x3 here. And here's another system of three equations and three unknowns. Now, there's several ways to solve a system of equations, and we'll use matrices later in this chapter. But for now, I want to go ahead and show you some ways to solve a system without matrices. The first method I'm going to talk about is the graphing method. And this is probably not one of the most favorite methods, but it is a good method to learn because you are forced to graph equations when you do this. So the graphing method, basically what you need to do is graph the two equations and find where they intersect. So on this system, the easiest way to graph most equations is just to find the intercepts. So if you look at this first equation, 2x plus y equal 8, if you were to let x be 0, you would get y equal 8. So that would give you the y-intercept. And then if you let y be 0 and solve for x, 2x is 8, so x would be 4. So you would get 4, 0 for the x-intercept. So this line goes through 0, 8, which would be up here somewhere. It's off the graph. So 0, 8 is up here, and then 4, 0 would be right here, and then you just take your ruler and draw a line through that. Now the other equation, if you let x be 0 and solve for y, you get y equal 3, and then if you let y be 0 and solve for x, you get x equal 9. So the y-intercept would be 0, 3, which would be right here. And then 0, 9, again, it's kind of off of the graph, but it would be over here somewhere. So I was kind of limited on room here. But anyway, draw the line through those 2 points. And now what you want to do, and if you do this, you want to do it with graph paper so that you can see the grid marks. Now, these two lines intersect right here, and so we want to find that intersection. That looks like it's 3 to the right of 0 and 2 above 0, so that would be the point 3, 2. So the intersection would be the point 3, 2. One of the things that one of the disadvantages of using this method is, had the answer been some decimal number, like instead of 3.2, suppose it had been like 2.98 and 2.1 or something like that, then it would be hard to determine what the actual answer is if it had been a decimal number. But you can always check your answer to make sure. If you go back in here, if you plug 3 in for x and 2 in for y here, you'll get 8. And if you plug 3 in for x and 2 in for y here, you'll get 9. So this does check. Now I'll only solve by graphing when we have two variables, because to solve by more than two variables would mean you have to graph in 3 or more dimensions. And you can graph in 3 dimensions, but it's a little tricky. And of course you can't go beyond 3 dimensions when you graph. So we'll just do 2-dimensional graphs. So 3 things can happen when you solve a system. I'm not going to solve these, you can read it, but I just want to basically show you the 3 things that could happen here. One thing that could happen is the line could intersect at a single point given a unique solution. When this happens, we have a consistent and independent system. So learn that name. So this system, this first system here, the lines intersect at one point, the point 32, and so that's a consistent and independent system. The second thing could happen is the lines could intersect at infinitely many points, and when that happens, it's said to be consistent and dependent. So if you were to graph this system, you would find that the two equations give you the same line, and that means that every point on this line is a solution to the system. And of course there's infinitely many points on the line. So this would have infinitely many solutions, so it would be a consistent and dependent system. And then the third thing that could happen is maybe they don't intersect at all, like when you have parallel lines. In that case, the system is said to be inconsistent. So on these two lines, if you graph these two lines, you'll find that you just get a set of parallel lines that never intersect. And in that case, we would say no solution, and it's an inconsistent system. Okay, let's just look at another one here. Now I'm graphing these using the x and y intercepts. Sometimes it might be easier to write it in slope-intercept form and use the slope in the y-intercept, but in these it's not, so I'm going to use the x and y intercepts. So here, if x is 0, then minus y would be 3, so y would be negative 3, so that would give me a y-intercept of 0, negative 3. And then if you let y equal 0, you can see that x would be 3, so that would give me an x-intercept of 3, 0. So this line goes through 3, 0 and 0, negative 3 down here. And you draw the line. Just get your ruler and draw the line. Now the other one, if you let x be 0, you get y equal negative 1, so that gives me a y-intercept of 0, negative 1. And then if you let x be 0, you get negative 1 as well, so you get an x-intercept of negative 1, 0. So this one goes through negative 1, 0 and 0, negative 1, and then you draw the line through those 2 points and you get the second line. And then they appear to intersect here, which is 1 to the right of the origin and 2 down, so that would be the point 1, negative 2. And again, you should check that to make sure. Okay, let's talk about if you have to graph a line of the form x equal a constant, that's going to always be a vertical line, and a line of the form y equal a constant, that's always going to be a horizontal line. So, for instance, x equal negative 3 is a vertical line that contains the point x equal negative 3, y 0, and y equal negative 3 is a horizontal line that contains the point 0, negative 3. So if I wanted to solve this system by graphing, well, the first equation I would graph like I've showed you before. I would cover up the x value, solve for y, and I'd get y as negative 3 for the y-intercept. And then if I cover up the y value and solve for x, I get 3, 0 for the x-intercept. So this goes through the point 0, negative 3, and then up here is the point 3, 0. And then the line y equal negative 1, well, that would be, based on what we said up here, that's just a horizontal line, and that would contain the point negative 1. It wouldn't cross the x-axis. It only has a y-intercept. So we just draw a horizontal line that goes through this point 0, negative 1. And now when we solve this, well, you already knew the y value. The y value was basically given in the second equation to be negative 1. So we know that y is negative 1. And so we just need to figure out what the x value is. And if you look at the intersection, you can see the x value of the point of intersection of these two lines is 2. So the solution would be 2, negative 1. I wanted to go back and just show you the other way you can graph sometimes. So let's say we wanted to graph this bottom one here, x plus 3y equals 9. If you wanted to, you could solve this for y in terms of x. So if I solve this for y, I would get 3y equals minus x plus 9. And then if you divide everything by 3, you would get minus 1/3 times x plus 3. And this is actually the slope-intercept form, where the coefficient of x is your slope, and then the constant is your y-intercept. So the slope is negative 1/3 and the y-intercept is the point 0.03. So you can see here I've already got the y-intercept highlighted here. And so since the slope is negative 1/3, since slope is rise over run, since negative 1 is the numerator, you could say, well, I'm going to rise negative 1, so go down 1, and then run 3, 1, 2, 3, and then that would give you that point. And that's really all you need in order to graph it, is that point there. Just a minute, let me get this to work. So you would get that point, and then you could connect the dots to get your line. Now sometimes people teach you to do it again, so we could go from here and go down 1 and then go 1, 2, 3, and we could get another point. So anyway, that might help you draw a better line if you had 3 points, but that's just another way that you can graph a line, is by finding the slope and the y-intercept. I'm going to go ahead and move on into the next section where I'm going to show you how to graph by substitution and elimination method now.